Hello, class, the receiving students and teachers. Hello. Thank you all. You may be seated. Class, the receiving students and teachers, this is lesson 85. We are still on the same strand, which is science in the home, substrands using energy in the home. Our learning outcome: investigate how we use force in everyday life. The unit for this lesson is still on forces in everyday life. Now, receiving students, the class and the teachers, this is going to be our last lesson on forces. Now, before we go to our topic for this lesson, I'd like to have Michaeline Bagley, please. Jubilee Sconti, please. If I can have you four out there. Now, I'd like the class to, class as well as you, the receiving students, I'd like you to observe closely to see what our friends are going to do for us. Okay, let's see, I have a line here. Now that's my line. Let's see what these are going to do. We are going to have Michaeline and Bagley first. Michaeline, on the side, Bagley over here. Observe closely receiving students and the class. Okay, let's see what these two will do. Your legs there. Your legs on this. On this. Okay. Bagley, yours here. Okay. They're going to pull each other. See. Okay. I can't see you trying. Okay, thank you, thank you. So that's Bagley and Michaeline. Let's see Jubilee and Sconti. Yep. Your feet like your friends have done. Jubilee, come down. Okay. Let's see. Okay, thank you. We've just seen your friends, receiving students, we've just seen your friends demonstrate what we will be looking at in our lesson today. Now you've seen a girl and a boy and two boys. Now our lesson topic is balance of two forces. So what you have just seen is demonstration of two forces. Okay, let's see. You should have all these materials needed for the lesson. Class and the receiving students, teachers, if you are not able to have a spring balance or force meter with you, I would encourage you to observe what the model class is going to be doing for this lesson. Now, please, class, I'd like you to check to see that you have all those materials there with you. Now, first instruction. I'm not going to go through the instruction. Class and the receiving students, I'd like you to see the instruction on the screen and do as it says. Please, you can start now. Move your hands quickly. Not too close, not too close. Don't make the hole too close. Further away, because if you make it too close, and you might tear the paper as you go through the experiment. think you're using this lesson. Second instruction is up on the screen. Okay, that's okay. There are about 3 things that you are to do within those 2 instructions. You have to make 4 holes on the cardboards. That's the first thing. Second, you have to tie threads to the holes. And third, it says, use 2 spring balances to pull from each end. So there are about 3 instructions on the screen. Okay, what you do, you tried it already, yeah? That will be too long. So, you need to put it on the passing to flowers. While you are working, you should be all discussing together. Check to see what happens. Observe. Please observe. You see your friends already working. Thank you. This group is already, I hope you are observing. You have observed to see. You have to follow what it says there. See, you've already done the first one. That's to make 4 holes on the cardboard and attach threads, which you have done. Then you use 2 spring balance. You have done that. You can go to the next. Now we should have already have 4 holes. We should have tied threads to those holes. And we should be now using the 2 spring balance to pull from each end. Thank you, Clement and his friends have already done that. Let's see that you others do the same. The third instruction is up on the screen, class and the receiving students. Observe to see what happens to the cardboard, as well as the force meter. You see what it says for instruction 3. You have to observe closely. Oh, yeah, okay. Where do we put the fan? Come. You come. Oh, in here. Oh, okay. You see this? observe. You observe to as you pull the cardboard from both ends. You have to observe. You sit properly. Turn around. Okay. Now let's see. Walter, you have to stand up. Yeah, so you are able to look at it properly, yeah? You too, stand up, Win, so you are able to look at what you have there. Now, you see the third one, it says, what does it say? Third instruction, what does it say? There on the screen, what does it say? Momoru? Get the reading. Momoru, you tell me what it says there. Stops moving. Okay, you see, you have to do that. You see, when the cardboard stops moving, you have to get the reading from both ends. And you write that one down. And you also have to observe the strings or the threads. Get up so you are able to see the reading there. You see? Okay. This side you have grams, that side Newton. So you have to see that. Don't make sure it's okay. Now it went right down. Now let's see. Where's your? Don't pull it very hard. Don't pull it very hard. You don't have to. You have to relax. Don't pull it very hard. Okay. Not so hard. You don't all to balance yourself. No, you have to stand up straight and do that. Okay, let's see. Make sure it stops moving. Okay. Where is yours? Okay, let's see. You have to. Let's see yours. Okay. So you look at the cardboard. Once it stops moving, you get a reading from Walter's end of the cardboard. You, Momoru, you get the reading from Win's end of the cardboard and have it recorded. Still, don't move. Now, let's, Win, you're pulling it too hard. Win, relax.
Relax, Winnie.
Relax, Winnie. Win, go back. Okay, don't move. Okay. You see, it's straight on. It moved that, but it was at what? Here. Yeah. So what's this? It's 500 grams. If it's 500 grams, then newtons is what? 5 newtons. Okay, let's see Momoru. Momoru, you see, okay? It's around 500 too. Okay? So if it's 500 grams, then it's going to be, newtons will be what? 5 newton, okay? You recorded that. Okay, thank you. That's it. You already finished now. You also to make sure you observe the direction of the thread. Read the force meter at both ends. Get your readings recorded. Let's see what you have. Okay. Okay, here it says, third one, here it says, get a reading of both balances and observe that. So reading, what did you get? Write it here. Write your reading there. You should write your reading there, see, on both force meters. Force meters at both ends. What were the readings you got? You recorded over here. Your friends can get one of them. So you use same ones. Wait, they finish. Sorry, if I can get this one, and your friends will. Yeah, you can use two different ones. Use this one. Okay, you see what it says, the third instruction on the screen, and you try to do that. You already recorded it, huh? Okay, so, okay. Thank you. Okay, good. We will have your answer because you're using a different word, so you will give us your answer. What's your reading on the force meter? Make sure once the cardboard instruction says once the cardboard stops moving, you what do you do? Get the reading. So you don't move a lot. Okay, they are not going to get the reading. You others who are not doing anything, you get the reading from both ends. Get up so you can have a good one. What's your reading?
500
grams. So if 500 grams you convert it to newtons will be 5 newtons. Good. Okay, record that. And you go on to this here. Thank you. Now, last instruction for the activity is up on the screen. Class and the receiving students, I'd like you to look at the instruction and do as it says. Now, you will see there are 3 sentences that are bulleted. Those sentences are to help you to write about what you have observed. One, it says how the 2 forces are balanced. When you did the experiment, how were the 2 forces balanced? What did you do in order for the 2 forces to balance? Secondly, it says what happens when 2 forces are balanced? What happens when 2 forces are balanced? And thirdly, how can you tell when 2 forces are balanced? Now, this question should help you to write about the experiment that you have done and what you have observed. Receiving students, as I said earlier, if you don't have the force meter, I hope you observe what your friends have done, and that should help you to write about what you have observed now. What did you write? Jubilee, did you talk about it? Melvin? You did experiment together, so you should talk about what you have done. There, like I said, I have 3 questions there put up to help you to discuss together and write what you have observed, you have done and observed. Someone from your group to present your findings. You have to have somebody from your group to present your findings, okay? So you have to write down what you see, like I said there, when you were doing the experiment, all the process you went through, all the steps you went through, making holes, and then you traded. But after that, when you actually did the experiment by pulling the cardboard using the force meter, what did you actually see? Where it says how were the 2 forces balanced? And what happened? What happened when the 2 forces balanced to the cardboard? What happened when the 2 forces balanced? Okay. You're actually looking at the cardboard to help you to answer. And also the force meter, see? And how can you tell that the 2 forces balance? You see there's water you're pulling on the other end, and when you're pulling on the other end, So you have, those are two forces, actually two forces pulling. So how can you tell that this one balances? How can you tell? Discuss about it. Okay, you discuss about it, come up with what you can, and I'll have somebody to present. You have questions there to help you to write about what you have observed when you were actually doing the activity. When you had two force meters, you had two people pulling. Those are actually two forces, okay? Two forces at both ends. So, how were the forces balanced? And it says, what happens when two forces are balanced? You were supposed to be observing what happens to the cardboard. Okay? And then it says, how can you tell when two forces are balanced? How can you tell? Discuss about that. Okay. Now, class and the receiving students, we should have already come up with writing about our observation. Now, I'd like to have Michael in. Now, before we go with sharing with you, the receiving students, on our activity for this lesson, we actually use two different force meters. We used, sorry. Okay, receiving students, and the teachers, we didn't have enough of each of these force meters. That is why some of your friends used this and some used this. So we are going to have some of your friends to share with you their findings using this force meter as well as this one here. Okay, so we are going to have Michaeline from the group at the back. They've used this force meter, so if we can have Michaeline to come and share with us what they have found out. And we will have Momoru and Clement to share with us what they found from here. Okay, let's have Michaeline. Come up. Thank you. Okay, we'll have Michaeline to share with us of their findings using this force meter.
Number 3 question, when the cardboard stops moving, get the reading of both balances and observe the thread's direction. My answer is 800 grams and the threads were not moving. Number 4, change the holes and repeat the same steps from 1 to 3. Our answer was just the same, 800 grams, and nothing was moving. Write down what you observed. The two forces are both balanced by the cardboard that is hanging in the middle. The cardboard and the thread stops moving when the two forces are balanced. When the two forces are balanced, nothing moves. The thread and the cardboard stops moving.
Very good. Thank you, Michaeline. Good. Now, 800 grams. If we want to convert 800 grams to newtons, Angie, if we want to convert 800 grams to newtons, how many newtons is that going to be?
Newtons.
8 newtons. Thank you. If you can, okay, we'll have Clement. Clement, Okay, Clement is not ready, but let's see the other group I made a mention of earlier, Momoru's group. Receiving students, this is a group that used this force meter, so let's have Momoru from the group that used this force meter. Thank you. It's with Angie there.
Why the cardboard was balanced is because the force of the force meter.
Can you come on again?
Why the cardboard was balanced is because of the force meter.
Okay, because of a force meter. Good, thank you for trying. Let's have Clement. I think that's the other group I said they'll give us their findings using this force meter. Okay, Clement says they are not ready. Who would, from the class, who would like to share with us of your findings using this force meter? Bagley, your group, is it? Okay, let's have Bagley and his friends.
Our group, we have come up with our results using the same force meter. We have come up with 350 grams. When we look in newtons, it's 3.5 newtons. How can you tell when two forces are balanced? By looking at the same results in grams and newtons.
Very good, thank you. Okay, thank you, class and the receiving students. Now, let's just go through quickly. It says, write about what you have observed, and you have 3 points there to help you to write of what you have observed. Now, when you did the experiment or the activity, you find that when the both forces at both ends balance, there is no motion. No motion meaning there is no movement. And you are observing the cardboard to see that there is no movement when the two forces are balanced. Now, also, the size of the force, that is using the force meter, you should have had both force meters with the same reading. That also shows you that the forces on both sides are same. They have the same size, so they are equal. Now let's go through quickly with a summary points. The first one, forces are balanced when there is no motion, meaning there is no movement, and that is what you should have seen with the cardboard. No motion, meaning no movement. That is with a cardboard. We just did it as an experiment to help us to understand that there is no motion to show that forces do balance or are balanced. Secondly, forces are balanced when two forces are in a straight line. Now the class, that's what you have observed during that activity, and I hope the receiving students, you have also observed what your friends have done to see when they pulled from both ends, the piece of rope or string were all in a straight line. Okay, class and receiving students, if you can help yourself by having someone from your group to write the third summary point and another write the fourth summary point. So once after this lesson, you can copy from each other's what you did not get done. Okay, our third summary point, forces are balanced when two forces are in the opposite direction. And the last point, forces are balanced when the strength of two forces are same or equal. And you have tried to find out that using the force meter. Class and the receiving students, we got the result, especially with the last summary point. The result for this we got from Michaeline was 800 grams, which is equivalent to 8 newtons. Now, with this one group got 500 grams, the other got 350 grams. When you convert that, you have 5 newtons, 3.5 newtons. Now, we may be asking why the other group got 500 grams and another 350 grams. Now, this depends on the force that you exert on the spring balance. Our key phrase for this lesson, balancing two forces. Our next lesson, what are simple machines? Now, these are the materials that we will need for the next lesson. Class and the receiving students, you are to provide empty 500 gram rice packets, or it can be sugar packets. You fill that, help your teacher and fill that with sand or soil. And I will provide you with a force meter and ropes. Once again, teachers in the receiving schools, with force meter, if you don't have, then I would encourage you to observe the class in the next lesson. And with that, thank you, class, the receiving students and teachers.